What is up, you guys? What is up? Sorry about that, just realised my audio would have been echoing there a little bit. What is up, guys? Happy Thransistor Thursday. I was like, oh, what sound? What has a TH? And it's a Thyristor. I know no one's going to know what that is. A Thransistor, there we go. How's it going, Josh? What's going on? What's going on, Stephen? What's going on, Ali? What's going on, Adrian? Exactly, time to crack on with the old repairs, bruv. How's it going, everyone? Tell me what you've been up to this week, eh? I swear this camera's like mega on some next crooked thing. There we go. Yeah, guys, tell me about your week so far. How has your week been so far, guys? Anything good happen? Anything shit happen? I'm going to plug in my front camera here with the multimeter. It's always good when we got that plugged in. Alright guys, just before we get started on the repairs, I'm going to play a little game with you. We're going to play a little game first of all. Right, guys, you guys that are with me so far, we're going to play a little game. We're going to play Calibrate the Bearvids microphones game. Okay, so I have a second mic hooked up here, which I would like to have for the stream as well, in addition to the one that I'm currently speaking on. I'm just going to turn the gain down a little bit on this one because I noticed that when I watched my stream back the other day, it kind of clips quite badly. So I'm just turn the gain down a little bit. There we go. Good, good, good. But I would like to have my second mic hooked up. The problem is that one of these mics has a delay on it. So I need to figure out which one it is. So this, like what the delay is. We're going to figure out what the delay is together by you telling me more or less, better or worse. So this is the current delay situation. Okay, so I'm going to change the delay values of one of these mics, and I need you guys to tell me when it gets better or worse. Okay. So. Okay, is that better or worse? Is that better or worse? 1, 2. 1, 2. So that's better. We're getting closer. Okay, how about that? Is that better or worse? That's 80 milliseconds. Getting closer. Same, okay. Getting closer, so I'll go down. So in that case, so this one needs less delay, and this one needs more. Okay, how about this? How about this? 1, 2, 1, 2. This is 40 milliseconds. That might have got worse. 1, 2, 1, 2. It's better again. 1, 2, 1, 2. Okay, maybe I'll go down to 0. 1, 2, 1, 2. How are we doing? Is that any better or is that worse? 1, 2, 1, 2. Bup, bup, bup. Bup, bup, bup. 1, 2, 1, 2. Bad. Okay. So 30 milliseconds now. 1, 2, 1, 2. Mic check. 1, 2. 30 milliseconds. That might be better. It might be synchronized nicely. I feel like some of you guys need to fast forward in the live stream a little bit. If you feel like you're behind in the live stream, then you need to just watch the live stream in ×2 speed, and it will catch up. Someone said that's fine, that's better. Okay, so that's cool. So 30 milliseconds on audio input capture is good. We've got 120 on JVC. So that means if I minus 30 from both, then I might sync up with the camera better. So now we've just got to work out what the camera is. So when I'm talking, does it look like my mouth is synchronized well with what I'm saying? Doesn't look like it to me on the screen. Looks like there's a bit of a delay. Boom, boom, boom. It looks like there's a bit of delay to me on the screen here. So slight delay. Okay. So if we go properties, oh no, not properties. If we go to, what is it, audio, what is audio properties? Let's see, if I take 30 away from both of these, so that should still now be the microphones synced. There shouldn't be any echo. Does that look better or worse with the synchronization with the screen here? Has that just got worse? Oh, it got worse. That's really strange. Okay, it got worse. Alright, we'll go back to what it was before, 30 and 120. That should now be in sync again. That's really weird, isn't it? You take away the same amount of delay from both. And like I would have thought if one was delayed to 30 milliseconds, one was 120, if I take away 30 from both, it should be the same sync. Damn. Alright, well maybe I'll just leave it on this, one mic then, and maybe I'll just go back to how it was before. I feel like this is how I had it set before. I had it set pretty calibrated before. So this now should be okay in terms of audio and in terms of picture. Is that synced up? I might just record a little video and watch. 1 2 1 2 recording. Let's just see how that looks. Oh yes, that looks synced up. Yeah, so OBS just crashed while I was trying to do that. Sorry about that, guys. I recorded a video and it just crashed because I guess it couldn't handle recording and streaming at the same time. So the camera should come back alive in a sec. Yeah, there we go. Camera's back alive. That's back alive. Okay, we're good to go. We're good to go. Anyway, good evening, everyone. How's it going? Let's get cracked on with the old repair stuff. So today we're carrying on with some of these in-phase amps I've got. I've got a bunch of in-phase amps to look at. So this one here is the 8704, which I'm going to assume is going to be a Class AB4 channel. Let's see what's up with this one. I probably should have tested it first because I've now broken the warranty seal. Not that really matters, but... Oh my god! Look at... Guys, you need to see this. This is factory. Whoa. This is mental. This is really, really bad. Factory assembly quality and stuff. Like, check this out, right? So this is a factory soldering, right? So all over the board, okay, all over the board here, there are these like bits of solder Look at all of this sprayed solder over the board. This is factory. There's like interweave cobwebs of like solder balls, all kinds of stuff over here. What even is this? Look on the terminals as well. What? What? What's that? Okay, this has probably got to be the single worst like factory soldering I've ever seen. I mean, and look at that. Look at this. What's this? It looks like that this board was like put together in factory, but then a bunch of changes were made after it had already been like soldered. Jeez. It's mental. Right, I'm going to take a wire brush here. I'm going to go over the whole PCB where there's all this stuff to break off all of this cobwebs of factory solder. I'm going to do that first, and then we'll have to turn the board upside down and get rid of it all. Crazy. It's like massive blobs of solder and all sorts in here. Like that doesn't look soldered very well. That looks like it's been resoldered, the RCA terminal. That screw's basically stripped. Look at the screw as well on the side. Where is it? This one. This screw has like kind of stripped metal, as if it's like someone's screwed it up with an electric screwdriver and not taken much care about it. Yeah, this is crazy. Right, so this is a 4-channel. I assumed it was going to be Class AB just because of the type of amplifier it is, but it is a Class D 4-channel. So we've got 4 channels of Class D using IRS 2092 drivers. Really curious to see what dead time mode these are in as well, what the switching frequency is, all that jazz. Looks like that the changes were only made to a couple of the channels here. So you can see this is a 4-channel amplifier, right? And we've got changes made in factory by virtue of the fact that we've got these terribly hand-soldered capacitors. There's a resistor there by the looks of it on this channel. Over here as well. This is definitely like an afterthought. Whereas on the other 2 channels, this all looks like factory. There hasn't really been any changes made apart from maybe on this diode here. It's really strange. It really looks like this one's been messed around with a lot after it was, after it had all been soldered by the part picking machine and all sorts. Really strange one, this. Right. Well, first of all, let's check to see whether there's any dead FETs. With all that solder floating around, I wouldn't be surprised if something kind of shorted out some of the components here. So we've got output FETs here. Oh, bloody multimeter camera. I need to cut the end off and solder on a proper solid USB wire rather than the stupid thing that it comes with. Snake, deactivate, reactivate. There we go. Still no good, is it? Look. This is just the worst. This is the USB end, right, for my camera that I have pointed at my multimeter. As you can see, you can choose between micro USB or USB-A. But unfortunately, the type of connection it makes on these little pins is absolutely horrendous. So I have to spray it with some isopropyl alcohol, give it a rub with this thing just to kind of freshen up the contacts, then it usually works better. But you have to do that every time. So I'm just going to cut that off because I don't need it. I don't need micro USB on it. I'm just going to cut that off and solder on a regular USB. So now if I reactivate it, it should be okay. There we go, you can see it now. Fantastic. So, output FETs, let's go. This one seems okay. No weird values there. No low resistances or weird values on this channel. Let's go up here to the top channel. Okay, no weirdness there. Looks okay. Nothing there, nothing there. Okay, don't seem to have any dead FETs. Power supply, you can just generally check resistance between these two. Oh look, the camera's bugging out again. And if I hold it at this angle, it cleans up. Super annoying. Yeah, nothing weird on here. The capacitors are charging on the power supply side. So I'm going to go ahead and shove some power in here and see what happens. Oh my god. What wine do I drink? Palm trees. I like dry wines. I like Spanish reds, Spanish whites. I quite like French whites. Chablis is good. I like Faustino 1. I like Rioja's like my go-to for reds. Yo! The heavens just opened outside. If I still had my RTA mics hooked up, you would be able to hear the rain right now. Absolutely, the heavens just went red! It's absolutely torrential out there just now. I should have a window cam. Would anyone like a window cam for when I'm like doing boring stuff and you just look out the window? Not that there's much to see. Skies has got an MRP M500 by Alpine. Had this bad boy for long, sat a good period, but I kept it in my room. My problem now is it only plays when I crank it up full. So stuff only playing when you crank it up full is sometimes a dodgy switch or something like a physical contact in a potentiometer or a switch that just needs cleaning up with some isopropyl alcohol, or just by flicking it or like spinning it around a few times just to clean up the contacts. Or it can be, if an amp's got a relay, it can be a bad relay, but those amps that I don't think have relays. I don't think the M500 has a relay. So it could be a Class D drive circuit, yeah, a bit unlikely. I would say it's a physical contact issue in the preamp circuit somewhere. There's always a nice stiff drink as usual ready for you in Australia. Thanks, man. I appreciate that. Australia is full of nice people. I'd love to visit again. It was a good time when I went before. So we are going to power up now. Have a little cheeky look on the scope screen. See what we have going on. So we're going to probe the 4 channels, low side drain on the MOSFETs. Just pulse the remote a couple of times just to get a little bit of rail voltage built in here, and then make sure that they're all in the correct places. So a couple of little pulses with the old remote, and we already have, by the looks of it, if I turn my scope to the correct setting, DC coupling, we have positive rail there, and this is low side, negative rail there. So power up. Yep, we have Class D switching, 0.8 amps of idle current draw. Okay, nice to see. 12 volts going in. We have a switching frequency of 325 kilohertz. I don't know what FETs we're using yet. I haven't looked under the little heat sinks, but judging by the idle current and the fact we've got 4 channels here, I would say these FETs are pretty fast and easy to drive. That's a nice low current draw, not much cross conduction there. So channel 1, nice class D switching, 325 kilohertz. Let's check channel 2. That one has 330-ish kilohertz, same frequency, nice and clean as well. Channel 3 has 325 again. Yeah, it looks alright to me. And channel 4, yeah. So they're all doing good. They're all switching nicely. Okay. Let's check for any DC offset on the speaker terminals at all. Not that we should have any, given the nice Class D switching we've just seen. No, it all looks good over there. Okay. Pin 9 of the RS2092. I'm just curious to see what voltage we have on that. That's here. We have negative 23.68, and if that's the same as VDD, I think it is. Wait, have I got the right pin? I might be thinking of a different chip. 2092S, yeah. I can't remember. But yeah, that's fine. So that looks okay. I'm going to grab some RCA wires now and just see if we get audio output, because otherwise this amp appears to be working okay. Line input on front, and we're going to put this amp into 2-channel mode so that we can check all 4 channels with just 2 RCAs. Crossover on full. Let's get the gain level. Let's get that down low. Let's get bass boost down low as well. Interestingly, the bass boost knob actually looks a bit burnt for some reason. Looks like there's been a soldering iron up on the bass. Actually, all of these knobs actually look like they had a soldering iron touching up against them, which is really strange considering this is brand new from factory. High pass filter down, low pass, bass boost off as well. And I'm going to go down on the level again. Just going to make sure that this makes some audio on all 4 channels. Okay, so channel 1 over here. Let's get the signal generator turned on. Hertz. Yep, looks good. Okay. So as you can see, we have PWM. We have modulation of the duty cycle here, which means that we're going to have some audio output. So if we go ahead to the speaker terminals, let's zoom out on the scope so we can see the audio sine wave. Turn the signal up a little bit. There we go. So we've got audio on channel 1, 2, 3, and 4. So this amp works fine. Nothing wrong with it. Waste of my time. So let's get this one back in the case and see if the next one's got a fault or not. The Thransistor from hell, exactly. Thransistor Thursday. I was trying to think of something electronics related. It began with a th. They got thyroid. Isn't thyroid something to do with your body? Thermistor. Thermistor Thursday. It could have been, but I liked Thransistor. I thought that was hilarious, so I put that. Can we get a comparison on the Smart 8 and the base 8K like you did with the 5K? I would love to, but I'm not going to buy a Smart 8 just to make a video. So I will do a Smart 8 video either when a customer sends me one for repair, or if Taramps decides to send me one for a video review. And given my negative review of the amp player, the head unit from Taramps recently that I did, I don't know whether Taramps will be too happy to send one in, but we'll see. So hopefully that's going to put to rest all of the absolute bum clouds that say that Taramps pay me for good reviews. No, clearly not. If you watch the Taramps head unit review I did, I clearly put it in its place as a pile of junk. I if I think something's good, then I'll say it's good. If I think it's bad, I'll say it's bad. Doesn't matter if you send it to me for free. Doesn't matter if you paid me. I mean, tabs don't pay me, but I'd love it if they did. I'd love it if they paid me, but they don't. But even if they did, if something sucks, I'll say it how it is. Thermal paste Thursday. Yeah, I like that. That's better. Do you think there's a future for lead-free solder, considering most repairers hate it? Yeah, lead-free solder is and has been used for many years in, when stuff is assembled in factory. Provided the device doesn't go wrong, there's no need for leaded solder, really. Technicians obviously love leaded solder because it just flows much easier, it's much nicer to work with. But yeah, like, for stuff that doesn't really fail too often, or if it does fail, it just gets thrown away, lead-free solder is what's used, and it's fine. Mobile phones, laptops, that sort of thing. I mean, obviously people do repair those things, but I feel like they're actually way more reliable than like car amps, for example. Exactly, they should have paid me for a good review. No, I wouldn't have done that. If they'd offered me like $1,000 to do a good review, I would have said no. Sorry, bro, this is shit. Alright, so that one's fine. I'm having to make notes of all these. This is the IPA 7804. So let's just write that down. Actually, I'll do this after the stream because I've closed it. So yeah, IPA 7804D, no fault found. Let's move on to this next one, which is a little baby one. This is the IPA 601. Ground on inputs, both came off. Okay, so it might just be a quick solder job. I've got loads more of these, by the way, these in-phase amps I need to get through, so I think this is the last one that I've got in the workshop with me. So if I get through this one, okay, I'll go and grab some more. So I don't generally look at a lot of these in-phase brand amps. However, the reason I've got so many at the moment is because I've just received like a pallet worth of them. These are all warranty returns. So the reason I've got a load of in-phase amps at the moment is just because I've just taken on all of their warranty work that they've had sitting in the warehouse for like 3 years. So, right, should I check this one works first before I start taking it apart? It said something about ground came off. I don't know. Let's have a look inside anyway and just see what we got inside. Might as well while we're here. What's good, my man Donnell? How's it going, buddy? Hey, yo, Donnell. Scroll back in the live stream just quick, and to the bit where I just took the back cover off the last amp I looked at. You'll get a nice viewing of the of what was inside that one when I first took the back off. It's pretty interesting. Is the Linus Tech Tips screwdriver any good? Yeah, this thing's pretty freaking awesome. I mean, I don't have anything to compare it to, but I like it. It's great. I haven't really used ratcheting screwdrivers before, so like this is the first one I've used, so I don't have a reference of what's good or bad. Right, single-sided PCB, a absolute haven for snapped cold solder joints all over the board, especially on the components that have high mass to them, that flex around a bit. So let's see whether we have anything shorted. It said something on the case. It said something about ground came off. What does it say on the box here? Ground on inputs both came off. Ground on inputs. They're talking about the RCAs? Oh, I see. So if you look at the RCA, right, this is how the RCAs are supposed to look. They've got like a little black ring here, whereas these ones, the little black ring is missing, and this Ah, the ground for the RCAs. Ah, yeah. See, these just come off. This is very common. But they just need bending back in a slightly different way. I can actually fix that probably without even unscrewing anything from the board. So basically you just need to take these off like this. And then put the rings back inside, and then you can put these, bend the legs on these so that they go in and stay in really tightly. RCA input shield, that's the thing. Right, so we've got line input. From factory these are just both black. So let's get my RCA's little drawer thingy majooby. And I can either give it black and black, or I can give it a red and white. What shall we give it? Got a white one here. Maybe I should give it black and black, seeing as that's what this was fitted with from a factory anyway. Yeah, we'll give it two new black ones. Right, what's the condition of these ground rings then? That one looks okay. That one looks okay as well. So it just needs these prongs bending outwards a touch, so that they really grip when you shove them in. Same for this one. Just need to bend that out a touch like that. Then I'm gonna have to do this upside down, I think. So we're gonna have to put these two little black rings. These are what go in the RCA ends to give them their colour. So if I stick them in here like this, get that in there, and then turn this upside down and stick that on. There we go, that's one. So you do the same with the other one. Flathead screwdriver just to help it on. There we go. Okay, two new ground rings on the RCAs there, and they are now nice and tight. They're not really coming off. You'd have to really tug at them. These type of RCAs, you can pull the rings off pretty easily. Like if you've got those RCAs that really grip the shield ring tightly, then these type of cheap RCAs, they come off really easily. But it's not like broken. You can just bend it back and put it back on and it's tight again. Alright, so that's that one sorted. I'll have to go downstairs and get some more of these bad boys to fix for you. But maybe I'll test this one first as well. Let's see, what is this? Is it a class AB? Yeah, a little class AB. Let's just test it. Make sure it's alright. Straight up, how's it going, my man? Good to see you again. Is Tiffany RCA worth it? Like, yeah, Tiffany RCAs are going to be more durable than these sort of RCA plastic blocks for sure. Doesn't really make a difference though, as long as you don't abuse them. Like the point of the RCA block is just to get signal in, provided that it gets signal in with a low resistance connection point, and you don't abuse it, you're not wiggling around and stuff, then it's fine. But you know, for an amp that's maybe 10 years old and it's gone through lots of different owners and being wired up and disconnected, disconnected lots of times, and the Tiffany RCAs are probably going to stand a better chance of, you know, surviving. Is a 4-channel Class AB better than Class D? It depends on the application. If you want high power density and efficiency from a small package, you want Class D. If you are looking for the best sort of sound quality, lowest percent THD, and you don't need lots of power, and you don't need the best efficiency, Class AB will be better. However, this is not necessarily one of the like nicest designed Class ABs. It's fine. It's built for a budget. Like, you know, this is a kind of budget amplifier. So the best Class D amplifier might sound better than this Class AB amplifier. It's not bad, and it's fine for an automotive environment. But what I'm trying to say is Class AB isn't across the board better than Class D. It depends on whether it's a good Class AB or not, and a good Class D or not. So yeah, let's just power this up and just see. Ooh, see if it works. Have I done the old flipper Ruby? I have. I'll tell you what catches me out, guys, on these amps every time, right? So when I'm looking at these amps, these in-phase ones to wire up, okay? So when I look at the amp upside down like this, see how it has the word power here? Okay, so when I'm looking at it upside down, I'm like, oh yes, that's the power terminal. So I put my power wire in here, and then this one's ground. I think it's just like a subconscious thing. You see the word power underneath the terminal, that's the power terminal. But actually, no, that one's ground power, and then B plus nothing. So that catches me off guard a couple of times. So let's have a look. Make sure we've got audio on both of these channels. So Class D switching frequency of this tiny little transformer is, sorry, not Class D switching frequency, SMP frequency, 34 kilohertz. Yep, nice small transformer, that's what you'd expect. Outputs, we've got rail voltages of plus minus 21 volts, very, very low rail voltage. This is a small amplifier. No DC offset on either of the channels, so let's plug some RCAs in. Full range at the moment, and let's see. Yeah, there we go. Nice clean signal on one channel and nice clean signal on the other channel. So yeah, the circuit's fine. It was just the RCAs there that wanted sorting out. Oh yeah, that's one of the beauties of using the bench power supply. So I don't know if you noticed then. So when I had the power wires in reverse, then so I have a current limit on the power supply here set at currently set a little bit high at 6 amps. It's a little bit high. Usually I have it set about sort of 4. But if the power wires are reversed, then what happens is the voltage that you're sending into ground, and that wants to now find its way through to the 12-volt terminal, it passes through the sort of diode section of the MOSFET. So basically, all the power supply MOSFETs, which are connected across the 12 volts and ground through the transformer, the 12 volts of reverse current will basically find its way through the MOSFETs. So what I did then is I basically gave all of the power supply MOSFETs 6 amps across all of them. So however, say there was, I don't know, 4 of them. That's That's a little over an amp each, for a fraction of a second. I don't know if you saw how quickly I did that. When I turned the power supply on, I instantly saw that there was a red light for like constant current on the power supply. So I noticed that instantly, and it went off. I think it was like probably less than half a second. I'll be interested to see when I look back on the stream. So yeah, with these two wires, if I just touch them together like this to simulate what it was. If I turn the power supply on, I don't know if there's actually a camera angle for constant current. There should be. Let me make there be a little camera on constant current. So actually, there's a little space here, isn't there? Just underneath here. So if I go add to camera, I'm going to add a little source here. That would be really cool actually for you guys to see, because then you can tell when the power supply is limiting on when it's not. Video capture device, add existing. PS cam, okay, so this is the PS cam, and now I'm just gonna crop this to, it's just out of shot, ever so slightly out of shot. So if I go down like this so that it's in shot, there we go. I'll just recalibrate my other ones and then crop that in to constant current LED. And even though it's upside down, you can still see. There we go. So when this LED lights up, that's when the power supply is limiting current to whatever I've set. That's cool. Alright, so what I did was turned the supply on. I was like, oh, that's on. So it was like less than half a second. I was like, oh, current draw. Oh, high current draw. So it got it for like less than half a second. Like maybe like just about an amp. Actually, it would have been less than an amp because it was limiting the current. So it would have been like super tiny amounts of current. But yeah, that's why if you're doing amplifier repair stuff, you should never use like I've spoken to some guys before that have been wanting to repair their amplifier, and they've got like a bank of AGM batteries hooked up on their workbench, and that's how they're powering the amp up and down when they're like testing it for repair and stuff. And I'm like, dude, don't do that. Whoosh! Like one tiny mistake and you have no time. Your amp is on flames in like seconds. Have you ever repaired or tested tech amplifiers, TEC? I don't think so. No. Either we don't have them here in the UK, or there's very little of them in the UK and none of them have gone wrong. I only ever really look at amps that have failed. So if an amp hasn't failed and I've not been asked to repair it, then I won't have looked at it. Right, guys, you have to amuse yourself for a moment because I need to pop downstairs to where all of these amplifiers are stored. I need to grab some more to repair for you on the stream. So I need to BRB, put that one on. Not in loft. Getting more amps. So I will be back in a minute with more amps. Oh, there's a screw here. I might have left a screw off that one that I missed. I'll have to screw that on in a minute. Alright, some more goodies for you. We've got 1, 2. Right, there's more. Three, 4, and one more. Five. Right, we'll start with this one. Whew. When will you do more car audio stuff? Bass demos? Well, problem is, YouTube is kind of saturated with just showing off kind of bass content. Like, I've done some videos of the van. You know, there's only so much like showing off your subs with the bass as you can really do, and I don't feel like it's really teaching people anything. It's entertaining to some people, but like, there's only so much like blasting the bass you can really do and film, and for it to be exciting or entertaining, you kind of run out of, you know, stuff to do. I'm not a fabricator. I don't really enjoy building audio builds. Don't like the woodwork involved. Don't like the amount of time it takes. I'm more of a tinkerer. I like to sit at my workbench, nice cheeky glass of vino, and make stuff work. So I'm not going to ever really do like build vlogs or logs or anything like that, like EXO would do, or any of those other audio YouTubers. I do have plans to make more content on YouTube channel, more videos like teaching people, trying to explain reasons why things happen and why things work and why things don't work. I want to do a video all about clipping and how it's severely misunderstood. I want to do videos about where your limits are in your car audio system. Like, basically there's 4 limits that are stopping everyone from getting louder, and when you know, I just want to go over what happens when you tackle those limits, and you know, why that causes there then to be a new limit, what limit really you want to be hitting, rather, you know, out of all the 4 limits, which is the best one to be at, just things like that. So that's the kind of content I have planned, but just like blasting the bass, it's not really high priority. Do you ever get a repair or something nice? Do you ever get a repair in or something nice laying around and you decide to upgrade for more power? The problem is that to get more power out of an amplifier, there's only 2 ways of approaching it. So let's say an amplifier is 2000 watts at 1 ohm. So if you want to get more power at 1 ohm, you need to increase the voltage inside the amplifier. And the only way to do that is to change the transformers inside, you know, the coils, the transformer winds. So you need to give it more secondary winds, or just change the transformers, rewind them completely, change them out for different ones, whatever, or bigger ones. And that's quite involved. That's not really as easy as just changing out the MOSFETs. And once you change the transformer output voltage, you increase it, then the amplifier stage has more rail voltage available to it, so now you can get more VRMS sine wave out of it, therefore you do more power into 1 ohm. But the problem is that you most likely will also, because you've got more rail voltage, you'll probably need to change the output MOSFETs to be higher voltage rating. You need to change the rail caps, you need to change the protection circuitry, you need to change maybe the output inductors, the filter network. There's a bunch of stuff that you'll also need to change, not just the transformers. You need to change like loads of other components in the circuit, at which point it would just probably be easier and cheaper to buy a bigger amplifier in the first place. And the other way to get more power from an amplifier, which I've covered before, is to improve the ability for the components in the amplifier to pass high current, and then that allows you to wire the amplifier down below its normal recommended minimum impedance. So turning a 1 ohm 2000 watt amplifier into a 4000.5 ohm stable amplifier. You don't necessarily, depending on how much headroom there is in the transformers, you don't necessarily have to change the transformers, and it really varies, and it depends on how close to the limits the current circuit you're working on is, and what is close to its limits. So sometimes in an amplifier, the limiting component, the part in the amplifier that reaches its limit in terms of current first will be the transformer. Once you try and draw too much power from a transformer, it will saturate and kind of present a short circuit environment to the MOSFETs which are driving it, which is obviously going to kill the MOSFETs. So if your transformer is your limit, then it doesn't matter how much you upgrade and replace the power supply FETs, the output FETs, you beef up the traces, nothing will really allow you to get more power from that amplifier. The transformers are just going to saturate, and it's just going to, the efficiency is going to tank, and it's just going to heat up and get hot and not do much more power. But a lot of the time, the transformers in the amplifier actually have a fair bit of headroom in terms of current, and you can ask a lot more from them than the amplifier is rated for. There's also things you can do, like speeding up the switching frequency that the transformer is running on. A lot of the time, the switching frequency isn't really optimized in these car amplifiers, and it may be sitting around 25 kilohertz. And if you can bump that to, say, 60 kilohertz, 70 kilohertz, you're going to get a lot more power from that transformer. You're going to raise that limit of that transformer, the current saturation point, quite a lot by the fact that it's oscillating and it's switching much faster. So you can do that without having to change the transformer. Then once you know you've got headroom in your transformer, you can then go ahead and upgrade the power supply FETs and upgrade the output FETs, beef up all the traces, disable the overcurrent protection and stuff like that, and then you might end up with a pretty decent reliable 0.5 stable amplifier that's now doing twice the power that it was at 1 ohm. What's the lowest you've seen an amp wired at? Well, you know, you hear of people wiring to 0.125, especially in dB drag when there's known impedance rise. The lowest that I've personally wired my amps to is 0.25. I had a pair of Korean, the Xenon built half bridge amplifiers, and they were strapped at 0.5, so each amp was seeing 0.25. And I did that. I did that on a pair of DD3515s and then Z315s. And on the 3515s, the amps, they played it okay, but they weren't happy about it. They got hot very quick. On the Z3s and the Z4s, actually no, on the Z4s I had it at 0.25 for like 2 years. Sheesh, yeah. I had my LW audio 4.5Ks at 0.25 for 2 years on the DD-Z4s, and they freaking loved it because the Z4s have so much impedance rise that even though I was wired at 0.25, the amps were never seeing like below 0.8, like probably not even below 1 ohm, and most of the time for most frequencies probably seeing beyond like 2 or 3 ohms. So they were loving it. They never really got that hot. They ran really cool. The subs fucking loved it because there was loads of headroom. The subs had loads of power available to them. So yeah, 0.25 is the lowest I've ever really done. But yeah, you see all sorts. You see 0.125 and crazy stuff. Actually, probably in my very early years, when I was like 12 or 13 years old, I had maybe like 8 or 9 different speakers all connected in parallel to this old Rotel hi-fi system. I bet the ohm load for that was like super sub-ohm. So probably unknowingly I've wired low. The Z4s are okay. Sadly, I don't recommend them. They are plagued with spider suspension issues. They have really uneven braking, and the compliance of the rolls of the spider, sometimes one of the rolls will go really soft and the other will remain stiff. The others will remain stiff, and that causes the woofer to have like a kind of a bump or like a notch in its movement. So it'll be stiff, and then suddenly it will get loose, like at the end of its like stroke, and that causes all kinds of weird behavior when it's moving and excursion issues and stuff, and it can destroy the driver. So I already had to send one of my DD-Z4s back to Texas. sorry, to Oklahoma to have it reconed because it had a spider issue from factory, and I'm not really, I'm not really abusing these subs. The other one was absolutely fine. Just one of them had this issue that came back fine, but now after like I think it was like 6 months or so of just like average daily use, don't really slam them super hard all the time. The other one now has that same problem, so I'm just kind of like, fuck, Jesus. So like it only really is an issue when I'm pushing them really hard. They still sound absolutely fine up to maybe like 80% of their excursion range, and the way to resolve it forever would just be to make changes to the enclosure, maybe a larger port which would hold the cone stiller, like a smaller low side chamber in the 6th order and a larger port to hold the cones stiller, because the issue only happens at high mechanical excursion. So if I can convert some of that energy that is otherwise being in the cone, if I can put a heavier load on the cones and convert the energy into air displacement out of the port instead, I'd get louder and have less excursion, therefore wouldn't run into the mechanical issues I'm experiencing with them. The Digital Designs Redline subs, even though they're supposed to be cheaper and supposed to be the budget line, are way more resilient to any kinds of mechanical abuse and all sorts. The Redlines are weirdly seem to be built better. I'll just put it straight out there. Yeah, the USA line is supposed to be like proper amazing materials and stuff, but it's all too kind of hand built and hit and miss, like assembly quality and like triple joints, like breaking and spider roll inconsistencies and stuff. Whereas the red lines are kind of so mass produced in a way that I don't know, they're kind of they're very forgiving. You can really abuse them, and they don't really rip the triple joints. They just take it. It's really weird. Right, anyway, let's get started on this next amp. Which is this one here. Faulty no output / overheats. Okay, this is a 4-channel. I imagine this is Class D again. This way. Oh yeah, it says it right on the freaking box. Class D 4-range high current 4-channel amplifier. So it's probably very similar to the one we just saw. It's probably using IRS 2092 drivers. Let's have a look. Yeah, so Mad Jims says wiring higher ohms, wiring the coils in series gives a higher BL. But BL on its own doesn't tell you anything about the strength of the motor coil relationship. BL just tells you you calculate BL with the ohm load in mind. So if you have obviously the same sub with its coils wired in series versus wired in parallel, you'll obviously get a higher BL number with the series wire, but that doesn't mean that in series it has like twice the motor force. It doesn't work that way. There's actually another parameter that someone else, not Thiel or Small, has actually coined that takes into consideration the difference in impedance. It's something like, I won't get it right, but it's something like BL over Z or something like that, where it actually takes into account the ohm that you're wired to even out the playing field for regardless of what you've got your sub wired to give you a better indication for the actual driver's motor force, so you can compare it to other drivers that are different impedance and get an idea as to how their motor force compares. BL doesn't tell you everything. It only tells you the motor force of that driver in its current wiring configuration, and you can only compare it to other drivers that have the same final impedance. Holy bananas! Whoa! No wonder! Sheesh! Okay. Freaking hell. So we have an absolutely KO'd film cap. So basically the film cap here, it's after the inductor, it forms part of the filter network for this Class D channel. So the inductor and capacitor work in conjunction with one another. The inductor and capacitor together filter high frequencies. The capacitor, because a capacitor is a natural capacitor, is a natural high pass filter. So when this capacitor sees high frequencies, it will let that pass. And the capacitor is wired in series with the inductor to ground. So any high frequencies that are trying to make it through the inductor will be loaded. The high frequencies will be loaded by the inductor because they see a pathway to ground through the capacitor. However, low frequencies, like audio frequencies that you want to listen to, they aren't loaded by the inductor. They don't see a pathway to ground, so the inductor basically ignores them, and the inductor doesn't doesn't low pass the audio frequencies. So the inductor, acting like a low pass filter, needs the capacitor there to put a load across the inductor for the higher frequencies, Class D switching frequencies, so that they go to ground and they see a pathway to ground. So they're filtered by the inductor, but the audio frequencies aren't. So the capacitor here in question that has absolutely cooked, these usually get overheated and fail due to excessive clipping. When you clip the Class D amplifier section, a lot of energy actually gets dumped to ground through the capacitor because of the spikes when the duty cycle reaches 0 and 100% and it touches the rail. There's tons of spiking going on as the essentially as the Class C switching frequency stops and starts however many times a second, depending on the frequency that you're currently playing. So lots of spikes and almost like inertia pulses, like impulses from the inertia of Class D starting and stopping from the inductor, make its way through the capacitor. It gets really hot, overheats, and fails like this, you see. But they can also just fail because they're faulty. They're out of spec from factory, or they're dodgy, and they fail just under normal operations. So yeah, we're gonna have to pull the board out and remove that, replace it, and see if it's killed any of the other parts of this channel as well. Yeah, so this should look like that. It used to look like this blue one, but now it just looks like a... So yeah, let's get that out. Yeah, it looks like a bird crap, doesn't it? Looks like a bird pooped in there. BL over RE, that's the one, Adrian. That's the one that I tried to reference. Ferox says ohm load was too low and clipped. No, you get clipping more when you wire up. If your ohm load is really high, you will reach clipping point really early before you really get the drivers going. So you're more likely to clip an amplifier, clip limit, when the ohm is high. So if you have a 1 ohm stable amplifier and you wire it to 4 ohms, you're going to be clipping the absolute bejesus out of that amplifier to get any to get any power, to get any output from it. You're just going to be hitting the rail voltage limit really, really quickly. Whereas if you wire that amplifier to 0.5, then all of a sudden you've got so much more power available before you reach that clip limit that you're less likely to hit the clip limit before either your driver reaches its thermal limits or excursion limits or something else like that. Do you know in TIG welding they use a foot pedal to control the amperage, something that you maybe could hook up to your bench power supply? That's a cool idea. I actually like that. I mean, I already use a foot pedal for the remote turn on and turn off, so having a foot pedal to control the amperage, yeah, maybe. Although I could very easily do that already by simply hooking up a foot potentiometer. So obviously on my power supply here, I have this potentiometer that controls the current. So I could just wire like a foot controlled potentiometer to that dial and do it that way. But I like having the potentiometer there and just being able to set it and leave it. So this amplifier is using IRF-B 4227s in the output section. That's actually pretty decent. These are some pretty nice FETs, provided they're genuine. You cannot always trust the factories of these amplifiers to use genuine FETs, right? Honestly, as a company, say for example you are, I don't know, you're B2 Audio, right? You're in charge of B2 Audio, and you approach a factory and you say, hey, we want some 3000 watt RMS Class D mono subwoofer amplifiers. Send over a few prototypes, and maybe you have a bit of a clue about amplifier parts, MOSFETs and stuff, and you know the models of MOSFETs that are kind of good. Or whatever, you have an idea of what kind of parts you might want to use in your amplifier. So you say to the factory, I want to make sure that you're using 3205s in the power supply, or you're using 1404s, or you're doing this or that, the other. So the factory might send you over prototypes with those genuine parts in them. However, then when it goes to production, if the factory is dodgy, they will actually swap over to using some other much cheaper but weaker MOSFETs in the production unit, but they will re-etch them, they will stamp the MOSFETs that they're putting in with 3205, so that any photos or any customers or any returns or warranty work that's done looks like it has 3205s in it, but actually they're fakes. This has happened before. I have seen this many times before. Not many times. I've seen this a few times before, where amps from factory have come with fake parts. So it does happen. So this amp looks like it's using IRF-B 4227s. Maybe it is, maybe it isn't. The one way to tell is to test the MOSFETs in a transistor tester that will tell you the most giveaway spec for whether a MOSFET is what it says it is or not, to see whether it's as MOSFETs get more powerful, as their ability to pass current increases, the higher current MOSFETs will generally have a higher gate capacitance. It's just kind of a trade-off. It's kind of how it goes. Generally, really powerful MOSFETs generally tend to be quite hard to drive, have a lot of gate capacitance. So if you've got a MOSFET that's supposed to have a gate capacitance of like 11, whatever it is, can't remember the suffix on that. On my tester it might say like 11 something farads, or if it's nanofarads or millifarads or something. And you read one of these FETs from an amplifier and it's reading like 4. Then you're like, hang on a minute, that's way too low. This MOSFET should have a gate capacitance of between like 9 and 14 or something like that. And if it's reading like 3 or 4, then you're like, hey, this isn't actually what it says it is. But you can also tell just by looking at them. So the MOSFETs in this specific amplifier, these 4227s, the camera doesn't really do a great job of making this out. If I grab some thermal paste on my finger, I can kind of maybe show this up a little easier. IRF-B 4227s. So one thing to note is that they have the notch in the top here, which is good. This little indent here, this circular indent, has markings in it. Like it has a stamp marking in it, which is good to see. I would say that these parts probably are genuine. They look pretty genuine. The font looks about right. It doesn't look super skew with. The font is very consistent. The positioning is very consistent. Yeah, we have these notches here. This stamped circle doesn't look like it's sanded down. Doesn't look like it's been like sanded flat. So yeah, I would say that these are probably genuine parts here. Where did I just put my screwdriver? Here it is. Sam, what do you think will cause a Korean half bridge to work on the bench but output MOSFETs burst when the customer hooks the amplifier up on a vehicle with high current bank. On bench, all Class D switching is 100%, is 100s. So that's a tricky one. I have seen it before where an amplifier will work absolutely fine with, say, between 9 and 12 volts worth of input voltage, but as soon as it's given 14 volts, parts will fail. So it depends whether the test bench that you're talking about here in question has a variable voltage power supply and it's been tested at 14 volts or not on the bench. But secondly, you can have weirdness happen if an amplifier's got a fault in one of its auxiliary supply voltage circuits. Then turning it on with a bench power supply that's low current, the amplifier will actually turn on quite slowly. So the rail voltages will build quite slowly, and then only when the auxiliary voltage supply levels are at the right point, all the control circuitry will come alive, and it turns on in a slightly different fashion to how it turns on when you've got tons of current available, and the second the remote is applied, the rail voltage is just like boom, and they're just like there. It is a slightly different sort of startup behavior. So if there is an issue with one of the auxiliary supply voltage circuits, you can have differences there. But it's kind of hard to say. That is a bit of a weird one. I have definitely seen it before, but there's not like one common problem that causes that across the board. You need to really sort of look into it and analyze what's going on there. Oh, bloody hell. Why do you not use an electric screwdriver? So I've covered this many times before. The reason I don't use an electric screwdriver is for undoing screws, the time saved really isn't that much. Secondly, the amount of screws that you have to undo and do up again, actually holding an electric screwdriver like at arm's length in front of you like that for an extended period of time is actually very taxing and kind of gets sore after a while. Secondly, for doing screws up, these aluminium heat sinks are made of cheese and the screws themselves are made of cheese. You need to feel the torque. You need to be able to feel the instant that righty-tighty starts becoming a righty-loosey. If you're using an electric screwdriver, you have absolutely no tactile feel of how this screw is doing up. You don't know really whether it's being cross-threaded, or you don't know whether it's kind of getting to the point where the screw's going to snap, or if it's going to start threading itself in the heatsink. Always a manual screwdriver when you're working on these kind of heat sinks. I've learned that from experience. I did used to use an electric screwdriver a little bit in the past, and yeah, it just caused loads of headaches. So manual screwdriver all the way for this kind of work. So let's go ahead and desolder, remove this capacitor that is toasted here. Let's take it off from the top of the board first, and then we'll pull the legs out from underneath. Sheesh. It just turns to nothing. This used to be this. It's like a piece of like lightweight foam. It's like nothing. Like when you burn a tea bag and it just starts floating because it's like so lightweight. Crazy. Okay, so I'm going to pull these legs out first, and then I'm going to clean up with isopropyl alcohol the components around this area and see what the deal is, see what survived and what hasn't. Why don't you see high-powered Class T? Do you mean like TriPath? Don't really know. Well, actually, I sort of do know. So I don't pretend to know a lot about TriPath. I haven't really done a lot of work with TriPath amplifiers, etc. But from the ones I have seen, the one takeaway that I've got from them is that they switch the MOSFETs or transistors, whatever they're using on the outputs, ridiculously fast. Like 800 megahertz, sorry, 800 kilohertz, not 800 megahertz, 800 kilohertz to 1 megahertz, stupidly fast switching frequencies. And For high power amplifiers, you need powerful MOSFETs with high current abilities. They don't like switching fast. They're not able to turn on and off that quickly. So for Class T, for TriPath to work, you need semiconductor components on the outputs that are very fast. And yeah, you know, if you were to make a Class T amplifier that was like thousands of watts, in order to get it to work, you need so many low-powered MOSFETs that were fast turn on and off that it would just be ridiculous. Class T has a poor damping factor at the top end. That's something I didn't know. That's cool information. Thanks for sharing. So I think I can probably pull these out from the top here. Because this is all covered in carbonized capacitor, I might not have a very good thermal connection to the leg itself, so I might need to go from the bottom of the board, but I just thought it'd be kind of handy if I could just pull it out from the top here like this. Oh yeah, it looks like it is working. There we go. There we go, nice. Alright, so now it's time to get the isopropyl, and an old towel would be good, just to wipe off some of that black stuff. I'll use a toothbrush as well. Damping factor, honestly, is not that important these days. Most amplifiers have more than enough dampening factor for pretty much any application you're going to use. Especially for subwoofer application, it's really not that critical because modern subwoofer drivers are so over mechanically dampened anyway that the amplifier's effect on the driver has a negligible effect. So your dampening factor is not really something that you need to worry about too much unless you're using drivers from the 80s and 90s that are extremely soft suspension and have very low motor force. Then, and you're using them full range, then that might be something I want to look into. But like I say, most modern amplifiers will have more than enough dampening factor for you anyway. There's a great article I read actually about dampening factor. It said something like above 150, like you don't even need to consider. Like above 150, there's no perceivable difference even using the worst kind of drivers that you would need high damping factor for. Above 150 is just kind of like, you know, beyond the point where any difference is really audible or occurs. Yeah, if you Google Google something like damping factor, what was it I googled? If you Google something like damping factor myth or something like that, there's a really great article it's a really scientific article. It shows all of the response graphs from different damping factors and how what it is, how it works, why it's not really an issue above a certain point. I think the Crown amplifiers that I used to have, I think the Crown Macrotechs, I think they claimed a damping factor of over 1,000. I might be wrong, but I seem to remember my Macrotech amplifiers were like stupidly high damping factor. Basically, the damping factor is just I think it's just the output impedance of the amplifier. So and by that I don't mean whether the amplifier is 1 ohm or 2 ohm stable. I mean that if you put a multimeter in resistance mode across the plus and negative output terminals of the amplifier while it's off, well, maybe it wasn't, but it's kind of the output impedance, the impedance of the outputs of the amplifier. So obviously when a speaker moves from an outward position to rest, when the coil moves through the coil gap, okay, it generates back EMF. It generates a current that works its way back up to the amplifier. Now, the lower the impedance that coil sees, that back EMF sees, the more dampened that motion will be. The more dampening that coil will have. I don't know if you've ever taken an electric motor. I don't think I've got one here, but I don't know if you've ever taken like an actual, spinning electric motor. If you short out the contacts, the terminals on the motor, and try and spin it, it doesn't spin freely. It feels very stiff to spin, and that's because the terminals are shorted, so it's very electrically dampened. That simulates a very high damping factor, because you've shorted out the terminals on the motor, so it's kind of electrically braking. The motor is trying to create electricity by you spinning it like an alternator or like a generator, but because it's shorted, the electricity that you're trying to create is shorted to ground in itself, so there's a huge amount of resistance on the motor when you try to spin it. The same thing happens in a loudspeaker when the coil moves through the gap. If there is a low resistance as far as the speaker is concerned across its terminals, that being the amplifier's plus and minus terminals, then its motion, its movement will be heavily dampened, so it won't ring, it won't oscillate and bounce around on its mechanical suspension. Yeah, having an amplifier with a high damping factor will allow the driver to return to home very abruptly and won't cause any kind of ringing or oscillation of the driver in transients, because it's highly electrically dampened by when the back EMF tries to drive that low impedance on the amplifier's terminals. Okay, so we've cleaned that up on the bottom. We've cleaned it up on the top. I'm just going to do a little bit more with the toothbrush. Now, I'm sure the inductor itself here is going to be fine. I don't know whether the MOSFETs have survived, so we're going to check the MOSFETs in a second. Okay, let's give it a go. Let's have a look at the MOSFETs here. See what they're saying. This multimeter camera is just the worst, isn't it? So, okay, that one looks okay. That one looks okay. Wow, the MOSFETs seem to have survived. I mean, these are pretty powerful FETs. I'm not surprised that they weren't really too bothered by whatever low resistance this capacitor was. Oh, what's going on with this camera now? Jesus. Okay, let's try and fix that. What am I doing? Yeah, this is in phase. This is a 4-channel Class D. So yeah, we need a new capacitor in that place. Now the capacitor that's being used is a 105K100. So it's a 100-volt capacitor, and it's a 105K, which I can never remember the what this is. 105K cap. You've got J and K, and they're different multipliers. It is, looks like it's 1 microfarad. Yeah, 105K is a 1 microfarad, 1 UF. It's not a U, but it looks like a U. 1 microfarad, 105K. So let's have a look through my drawer and see if I've got any capacitors that would work in that place. If not, I'll have to order one. Let's see, what's this? That is a 474J. That's not what we want. That is a 10NK400, not what we want either. .474J400, nope. So I can pop up in the loft and see whether I've got a donor board with that that resistance, that value. Oh, J equals 5%, K equals 10%. Ah, Nicholas, thank you very much for the info. I thought that the K or J was like a multiplier symbol, but it's a tolerance. Okay, that's cool to know. So J is 5%, K is 10%. Awesome. And then obviously 105. 1, 2, 3, 4, 5. Yeah, 1 microfarad. Yeah. Okay, cool. Thanks for that. Same as you repaired for me then. I don't remember repairing one of these before. I guess I repaired so many of them. Bear in mind, so obviously I'm doing I'm doing warranty repairs for InPhase. It looks like a lot, but it's actually not that much that I've got in at the moment. They haven't had a warranty repair guy for like years. So they've got a whole warehouse absolutely full of warranty returns. Some of them probably work fine and it was user error, they didn't use it properly. Some of it will have issues, but they sell literally thousands of amplifiers. And after like 3, 4, 5 years of selling thousands of amplifiers, there might be a few hundred returns. Like, this is going to happen. So yeah, it's going to look like there's a lot, but that doesn't mean that InPhase amplifiers are bad or unreliable by any means. It's just a big business and they're selling like thousands of stuff, and they haven't had anyone deal with their warranty returns before. So there's a lot of stuff. So yeah, I'm going to have to dig in the loft and have a look for a capacitor. Let's just do some Q&A real quick. Above 500 damping factor is referred to as the best SQ there is. Interesting that you say that. So the Crown Macrotech amplifiers that I had before, they're not really... like, obviously I don't know how they actually test, but in the industry they're not like renowned for being super beautiful sounding amplifiers. Maybe it's that they're just too revealing. Maybe they're just too flat. They don't impose a character on the sound. They don't have a sound signature. They're just very revealing and they're just very straight up. Low THD, great high damping factor. They just basically produce whatever they're given without touching it or coloring it in any way, which actually can give you the impression that it's a very not that fun, exciting, not that nice sounding amplifier. It can sound a bit cold, not a very warm sound. But that doesn't mean it's a bad amplifier. You feed it with a beautiful signal that, you know, has been either colored in the way that you like or well produced as it is, then it's probably going to sound amazing. I've seen some older subwoofer drivers that control damping with a special coil, and it calculated the position and adjusts for it. That's insane. I haven't seen that before personally. That's freaking awesome. Roderick, the MTX is fixed. Turned out to be something stupid. I sent you a video. Okay, I'd love to know what that was. I wonder about the dissipation factor of those caps. Higher dissipation factor, it will heat up. However, wider Q, lower dissipation factor, less heat up. Yeah, not sure. I mean, given the fact that only one of them out of the 4 channels here has failed, whatever was going on was either happening to just this one channel, it was being driven with a bunch of signal, it was just clipping the entire time, or because yeah, these output film filter caps, they absolutely die, they cook if you continuously clip the channel. Say you had a compact car with limited space, what would you go for? Or would you go for a Vibe Micro amp? Probably, well, it depends for what channels. For front stage, for tweeters, full range, you don't need much power for in-cabin listening. Like 30 watts is more than enough for tweeters, for a little 3-inch full ranges on the A-pillars or something like that. And you can get really small Class AB amplifiers with really nice, specs that will be super small, easily fit them anywhere in the vehicle. Vehicles are actually fucking huge. Even the small car has loads of space if you get creative for putting amplifiers. Amplifiers are low profile, they don't take up much volume. So if you get creative, you can put them anywhere. Regardless of what size car I had, I wouldn't worry about the size of the amplifier too much, especially if I'm going for an SQ build. For doors, yeah, I probably wouldn't use a micro because they're Class D. You're going to get some background hiss, not going to get the nicest response on the high frequencies, especially on those microamps. The dead time is quite high, so you're going to get higher percent THD at the higher frequencies. Wouldn't really do that. I'd go for a little compact Class AB that's really nice, like an old Genesis or something, DLS, or like an old Rockford, or I don't know, like JBL, something like, nicely designed, nice Class AB on the tweeters and the fronts. For the subwoofer, yeah, fucking use whatever you want. For the subwoofer, use whatever janky, disgusting Class D that you can find, because they don't care about that. So I'm just going to go in the loft for a second, guys. BRB in loft. And I'm going to try and find a capacitor that is this spec, a 1 microfarad capacitor that's at least 100 volts. I might end up with something that's greater than 100 volts, but yeah, we'll see. So BRB in loft. Can you do a quick explanation of what turn-on thump is caused by? I'll try and do a little explanation for you momentarily. Guys, do you want to see a magic trick? Do you want to see a magic trick? I am actually able to change my age at will. I am able to transverse 20 years into the future in less than a second. Are you ready for this? Right? I'm a time traveler. I can travel 20 years into the future. All I gotta do is just real hard, think real hard about myself in the future, and I can go 20 years into the future. Hey! Fucking 60-year-old technician at your service. How are you doing? This is now old ass Bearvids. And I tell you now, the year 2043 ain't so bright. Bunch of AI ruining the place. Right, let me go in the loft and grab this capacitor real quick. Right, this is interesting. Let me just come back to the present bear vids for a minute. 20 years in the past. Wow! All of a sudden my back feels less painful and I'm able to keep my opinions to myself. Anyway, I've got two amplifiers here from the two donor boards here from the loft. We're looking for 105, 1 microfarad. So I've got this amplifier here which has some 105J. These are 450 volt capacitors, which is obviously way higher voltage than the originals, which is fine. That's probably beneficial, if anything, in this one. So that's the correct spec capacitor. But also, I noticed that this amplifier has some 105J 100s, but these are tiny. Like, these are absolutely teeny weeny compared to the ones that this amplifier is fitted with. So what's that about? Why? I've noticed this before, in fact. I've noticed that the physical size, the physical dimensions of film caps for a specific value seems to vary wildly, possibly due to the internal chemical like makeup, what the capacitors are made from, the material, whether it's polyester or whatever it is. But yeah, the actual physical size seems to vary massively. Maybe someone who knows a bit more about capacitor like chemical makeup and stuff will have an answer for that. Can I use one of these really small 1 microfarad 100 volt capacitors, which is the correct spec, although actually the lead spacing will be wrong, but yeah, it's just kind of weird. I'll probably go for one of the 400 volt ones, you know, why not, might as well. The leads, actually, no, that the lead spacing will be too wide. Sheesh. The lead spacing will be too big, won't it? On these ones. Bugger. Might have to find another one in the loft. Yeah, the 1 amp's capsule's too small and don't think will fit, and the other one was too big. Different dielectric, different ESR, maybe. Oh man, thanks for the $5, Josh. Appreciate that, my man. Thank you very much. Hey man, nice to see you again. What do you think about sound digital amps without the cap after the inductor? I think they do have a capacitor after the inductor. Do they? I'm trying to remember. I'm trying to think back now. There's definitely film caps in those amplifiers. Are they not after the inductor? I'm sure they are after the inductor, but I know that you do get, especially on the Turms, the early Turms HD series, you do get like the Class D switch frequency makes its way to the sub, and the sub coil, being an inductor in itself, actually filters that out and doesn't really affect the sub in any way. Turn on thump. So if you've got a Class D amplifier, because the inductor has inertia on the initial cycle, the initial Class D switching wave cycle, it will make its way through the inductor without being filtered. So you get a little DC bump on the speaker terminals as a result of that, while the filter network, the LC network, the inductor and capacitor actually sort of starts working. If you think about it in a mechanical sense, think of the inductor like a flywheel, like a massy weighted flywheel. It needs a little bit of time to get up to speed. So during that time before it gets up to speed, there will be a little bit of DC bump on the speaker terminals as a result of that. For Class AB, you can have a little bump when the biasing circuit turns on and the outputs actually, start overlapping in current. If the bias supply isn't like super even, you can have a bit of a turn-on bump there, or if it's too quick. You can also have a turn on bump if the amplifier output stage turns on before the preamplifier stage turns on, before the auxiliary supply voltages for the op amps on the power on the preamplifier circuit, before those are built. If the amplifier stage is running and the auxiliary supplies for the op amps then finally reach the threshold for the op amps to turn on, you'll get a little bump there, as there's a little bit of a pulse sent through the preamp circuit. There's a bunch of reasons for it depending on the amplifier. No, man, I'm beyond the point of being sponsored by Keeps. Like, if I want to sort this out, I'm gonna need a fucking transplant, man. It's beyond any kind of redemption from chemicals. Yeah, turn on and off thump isn't really anything to do with capacitors. Well, there can be, depending. It can be if you're talking about the preamp VCC supply. If there's like really high value capacitors that load the supply being built and it delays it, then maybe, but not really. Best is probably polypropylene. Polypropylene. It's larger though, so that's maybe what these are. With inductor, it filters with 6 dB roll-off. With inductor and cap, it filters with 12 dB. That's really cool info, man. Thanks, Frank, for that. That's a really good tip. Right, anyway, so these two donor boards that I got from the loft, or the attic, I don't think I'm going to be able to use either of these, either the capacitors on these, because I think the lead spacing is either too big on this one, too wide, or too small on this one. I don't know if I'm going to have a donor board that has capacitors on it that are correct. I'm going to try one more time. I'm going to look at some other boards in there and see if I can find one. Going to do the magic trick again. Oh, my back. Oh, fucking hell. Oh, I don't like the new price. Oh, the prices of petrol is freaking ridiculous, man. Oh, my cheeseburger costs like 5 times what it should. Oh, Jesus, bloody hell. Oh, my back. Oh, fucking hell. Oh, that's better. Right, bloody hell. So I don't seem to have a 1 microfarad capacitor that's the right sort of lead spacing, so we're going to have to order one. So I'll put this amp down to one side. Oops. Fucking hell. Put this amp down to one side and order a capacitor for later fitment. I've got a nice little order building up actually on Farnell, so I can add it to that order. Just put all these bits and pieces away in a bag, keep them nice and safe. Move on to the next amp. It's true, Palm. It is absolutely true, man. Truth do be spoken. The loss of the follicles definitely adds like mega years to how someone looks. Right, next one up then is going to be this chunky boy. Going to be looking at this is the IPA 5001D. So this will be 2500 watts RMS, thereabouts. Does this one have a sticker on it to say what's up? Doesn't look like it. Close the loft door. No, I'm good, man. No one's coming down them stairs. Are you scared of ghosts, Henrik? Is that what it is? Are you scared that Bogeyman's gonna freaking come down that loft? It's been a while. Can't afford jail. How's it going, man? Yeah, it's been a little while. I did a nice stream on Monday, I think it was, or Tuesday. I can't remember. Now it was pretty good fun. Someone says this is a beast of a unit. This is a very unnecessarily large amplifier. Semiconductor technology exists these days to produce 2500 watts RMS from a tiny amplifier, from an amplifier that's probably a quarter of this size. Like, you see this side of the amplifier here, that's all the size you need for 2.5K. But yet this thing is taking up 4 times that size. It is unnecessarily big because its circuit design is like 25, 30 years old at this point. Man, maybe not 30, maybe 20. Have you repaired Digital Designs 12Ks? Yes, actually I have a Digital Designs Z2C that I need to repair that's currently sitting on one of my racks down there. Something got inside, like a piece of copper wire strand or something conductive got inside and shorted out the rectifier circuit. So it killed a couple of the rectifiers, 60 amp 600 volt rectifiers that thing uses, and a bunch of traces got nuked as well. So I've got that one lined up to repair at some point. Right, so let's have a look at this thing then. So we have 2.5 kilowatts in an unnecessarily large amplifier. We've got IRS 21844S, IR21844S drive ICs. We've got two separate amplifiers, one amplifier here, one amplifier here. Each amplifier is rated for 1250 watts RMS into 2 ohms. They parallel together after the inductors to allow for 2500 watts RMS into 1 ohm. We have 4 SMPs all paralleling at the rectifiers, nice small transformers, love to see it. These amplifiers are very susceptible to vibration damage because there are no supporting screws down the center of the PCB, so this thing flexes like crazy up and down when it's mounted anywhere near anything that vibrates. So this one didn't have a sticker on the box telling me what's up, so let's have a look and see if we have any shorted output FETs. Nothing so far. Nothing here, nothing here. No, output FETs seem alright. Power supply side, yep, no short there either, even though it beeped, it was just charging the power supply filter cap. So let's plug in some power wires and see why this is here, see why this is a warranty return. Repairing traces sounds like a lot of time. It's not too bad. I prefer to repair traces that I can see are bad than to troubleshoot a really strange fault and try and, you know, find the faulty component in like a massive complicated circuit. I'd much rather just repair traces. Because with trace repair you can physically see what's wrong and you can see how to fix it. Whereas with some really complicated drive circuit fault you can't really see what's wrong. And it can be really headaches to figure out. Now, when I say that this is a 20-year-old circuit, I don't mean the amplifier is 20 years old. I mean that the circuit design was like designed 20 years ago, but they're still freaking churning these ancient things out because it doesn't cost any money to keep producing them. It costs money to R&D a new modern circuit based on modern components, but it doesn't cost any money to just keep producing the same shit over and over again, you know? Make a live stream for that big DD amp. I might do. I might even do it. I was going to say I might even do it on today's stream, but it's actually kind of hard to get to. I'll have to clear out a few bits over there to actually pull it out of the shelf, so maybe next time. Okay, cool. Let's turn the power supply on. And, oh, I need to adjust my camera here, actually, because I adjusted the power supply, didn't I? Up here, so let's just quickly sort that out. Uh-oh, what did I do? What did I do? There we go. Somehow I managed to flip that without intending to. There we go. Let's get that over a little bit. There we go. Okay, cool, cool. I might even actually add a constant current thing to this. If I go video capture device, add existing PS cam, let's add a constant current LED to this screen as well, because that'll be really useful, I think. CC, constant current, slap that in the middle between those two. There we go, that's good. And you can see when the supply is actively limiting. Got 5 amps available. Let's turn the scope to a setting that can read the drive waves. So power supply, check we've got PWM here. Yep, a little bit of PWM. As you can see, it's limiting the current nicely there. Rail voltage, we have negative rail down there at negative 20 volts already. No DC on the low side drain, which is good. High side, yeah, positive rail, 20 volts. No DC on the gate or source. Looking good so far, so let's keep our probe on the low side drain and go for full power up, see what happens. as always, with these amplifiers, we have the 100 ohm output section load resistor after the relay for some stupid reason. That's a design flaw. So the amplifier only starts self oscillation when the relay clicks in, which is not the desired behavior. But it is what it is. It's just been how the way it's been built. So yeah, we have Class D switching. So let's get some RCA signal and see if this amplifier works or not. I can't see any visible issues here so far. So let's go line input here with the RCAs. Just connect one for now. Turn the gain down because most of the time these amps come in and the gain's maxed out. Okay, the gain was on about half. Subsonic is on about half. Bass boost on about half. Everything's on half. Literally. So many times. Like every single dial was on like exactly half. That just screams to me someone doesn't know what they're doing. They're just like, oh, I'm not sure. I don't want to put everything on full. I'll just probably put everything on half. It'd probably be alright. Exactly. The size of this amplifier. This physical space, you could build a 10K amplifier in this space with modern components. It's complete bullshit. So let's power this up and see if we've got audio. Gonna go down to about 9 volts on the power supply, keep it nice and safe. Okay. Ooh, some sounds. Oh, we've got a lot of signal going in, that's why. I realised I had my my signal generator turned up really, really high for a moment there. There was a lot of clipping noises, I don't know if you heard that. So yeah, we have PWM, we have varying duty cycle, so that means we have an audio wave on the output terminals. So this amp seems to be working just fine, which is what happens a lot on warranty returns. Maybe someone didn't know how to use the amplifier or wasn't able to set it up correctly. So yeah, that's a nice clean sine wave there. So what I'm going to do though is I'm going to give it a little tap. I'm going to slap the board around a little bit just to make sure there's no like intermittent connections or like stuff that's maybe shorting out somewhere. That seems alright. Let's click onto slave mode. Yep, master slave switch is working fine. Yeah, this amplifier seems fine. Nothing wrong with this. So it was probably returned for some reason. Maybe the user couldn't figure out how to hook it up properly, or they thought there was a problem with the amp and it was actually a problem with the sub or something like that. But yeah, no issue here whatsoever. This amp is perfectly fine. So let's move on to the next one. Oh, these are bloody hard to handle. Bevids, have that film caps acting like free clip detector. Oh yeah, exactly. You can hear the buzzing when the amplifier clips due to all of the massive spikes that get sent through the filter network. I don't know if you could pick that up. I don't know if the microphone picked that up on the stream, but yeah, it was when I first turned this amplifier on, the signal generator was turned up stupidly high, so I was clipping the absolute balls out of this amp for a minute then, with no load on the terminals. So these, for those of you that are asking vape questions, these little disposable things, these are shit. These are nonsense, really. The only reason I've got this is because my mate my mate comes over, he goes through one a day of those, which I think is mental. I don't really vape. Like, I like my ADHD that I have. I really like having something to do with my hands. I love the kind of tactile feel of like using a vape, if that makes sense. I don't really need the nicotine in it, but when he comes around, he just always leaves one. Like, so I love the taste of them. Like, I have a massive sweet tooth. So if I wasn't having the vape, I would probably be eating biscuits and shit. So I have a massive sweet tooth. The ADHD in me loves like the tactile feel and the kind of, you know, using one. But I don't need the nicotine. Like, I could have 0 milligrams and that'd be absolutely fine. It would satisfy my sweet tooth. It would satisfy like the nice feeling of using it and the taste and stuff like that. But I shouldn't really be using it. Like, I don't need I don't have a nicotine addiction. I don't need to use it. But it does feel nice, and I guess it enhances the focus a little bit, maybe. I don't know. But these are disposable. They're meant to be disposable, right? And these are a bloody nightmare. They have little lithium batteries in them. The stupid thing is, the lithium batteries in them are these. And these are rechargeable. The lithium batteries in these little vape things are rechargeable batteries, but they're marketed as disposable. So people are throwing these things away when these batteries are rechargeable, like perfectly. You can recharge them, which is stupid. So what I've noticed is, because I'm a very occasional user of this, I don't like go through one a day, I tend to use up the battery before all the juice is used up. So as a result of that, when the battery runs out, I just like open this, recharge the battery, put it back together again, and you get like another use. You get a whole another use cycle out of it before the juice dries up. So yeah. These are rechargeable. I do recharge these sometimes. And actually, even once the juice is used up, because these are such low power, the coils don't really burn that easily. Like, the coil's still fine. So you could rejuice it. If you kept topping the juice up with your own external juice and just kept filling up the little juice canister in there, the little carton thing with the cotton in it, you could probably use these like and keep recharging it for a long time. Eventually, the coil would kind of go bad, but... But it's actually a massive problem. And so these are pretty big in the UK, these disposable ones, and people are using these like cigarettes, obviously, going through one a day. So, like, you know, in a month, someone will throw away 30 of these. So in the average garbage truck, in the average, like, you know, dump truck that's taking away the rubbish, the trash, there'll be hundreds of these things. And when it all gets compacted, these lithium batteries will like vent and break, and they'll short out. And garbage trucks are setting on fire all over the UK, going up in flames. Recycling units, or rubbish units, disposal places are catching fire, having massive fires because of just the absolute influx of lithium batteries from disposable vape pens. Absolute nightmare. So I'm not throwing these things away. I've got a couple of these batteries here. I'm keeping them for projects. Like, these are 3.7 volts, which basically equals 2 AA batteries in series. Really useful for those cheap like LED light decorative things around your house you get that take a pair of AA's, or even actually TV remotes take a pair of AA's, or take a pair of AAA's. You can replace that with one of these, and it will last forever because it's a lithium battery. And when it does die, just recharge it. You get another 5 years out of it. Keep the batteries. Exactly. Yeah, Josh Holden has the correct idea. Yeah, exactly. Just keep putting juice in them, and they're fine. Frank says this has security reason in transport. They are shipped empty and they're charged at the target country. Oh, okay. that kind of answers my question. I always wondered, why are these disposable vape pens using rechargeable lithium batteries when they're meant to be single use? But obviously, if they're having to be shipped over empty due to shipping like regulations, they can't be charged, then obviously they need to be rechargeable so they can be charged in the country of, you know, where they're going to be sold. That does make a lot of sense. Comes with a bass knob, but no wire. Oh no, the wire's in there. Okay, it does come with a wire. Because these are obviously all warranty returns, so a lot of the time people just don't bother returning the bass knob because it's wired into their system or whatever, so it's always interesting when you get the bass knob back. Alright, what have we got next then? Got another big one, but this is something a little different. This is a really old-fashioned Class AB. This is a big Class AB 2 channel, I think. Yeah, the amps come with a berth sheet, however, I don't know the legitimacy of the berth sheets. I've seen, I don't know for sure, because I haven't, you know, confirmed this, but I've seen some similar kind of brands that are just buying amplifiers from China like that. The berth sheets are, for some of the brands that I've seen, aren't genuine. So what the factory will do is they'll have, like, say 20 different berth sheets that they'll just, like, with different figures on them, slightly different numbers, that they'll just like randomly shove into the boxes to make it look like they've been like berth tested for power. I don't know if that's the case for In-Phase because I haven't checked, but I can't remember what brand it was, but there was one brand and I got like a sample of maybe like 20 or 30 different people to send me a photo of the berth sheet in their amplifier, and not only were the numbers like exactly the same, there was like maybe like 4 or 5 different values that were all the same. So like there might have been like a bunch of people that sent over one that said like 2568, and then like a few other people that sent over ones that said like 2534 or something like that, and the actual like pen strokes were identical, so they weren't like handwritten. They were like looked like they were handwritten, they were just printed and copied. I don't know if that's the case on these ones, but I know that that does happen in some brands to make it look like you've got a genuine berth sheet. Hey! Oh, nice! Someone has someone has screwed this end plate on after putting the plastic on. Why would you do that? Why would you do that? It's not screwed on, it's just very, very tight on there because the plastic's in the way. Just gonna have to pry it off. Oh, Jesus Christ, man. There we go. Okay, so again, I don't know the issue with this amplifier. I don't know if it even has an issue. It's a warranty return, so it could be the customer just didn't know what they were doing, wired it up wrong or something like that, or didn't get any signal, had an issue with the sub. So I'm just going to plug it in first and just see what it does. We have a current limited supply, so there's no dramas there. These amps, these ones specifically, can suffer from vibration damage, but it's like they're single-sided PCBs if they're the same as they always have been, and they suffer from like bad solder joints because single-sided PCBs have a lot of leverage of the components of the single solder joint on the back. So large components like big caps or big resistors that are hanging off the board can really kind of like crumble the solder joint underneath them very easily. So let's just, there we go, let's plug in some RCAs, see what's up with this one, if anything. Channel 1, channel 2. Let's sort out all the settings on here, go for full range. Super bass knob, nope, let's not have super bass. Subsonic off, level, down, up about third. Okay, cool, let's turn the power supply on. So no excessive current draw from the power supply, meaning that the power supply FETs are probably fine. Power up. Power up, he says. And we have absolutely no current draw from here. No current draw whatsoever. And no operation. Let's turn the voltage up a little. Maybe this one doesn't like 9 volts. Okay, so yeah, we finally have an amplifier with a problem. Oh wait, hang on a minute, there's no fuses. There's no fuses in the side. Okay, maybe this one does have a dead power supply. If it's blowing fuses, alright, let's just shove a random fuse I've got here in for a second. Okay, let's put that in there. So now let's see, I'm going to turn the current right down. I'm actually also going to turn the voltage right down of the supply. So let's start. Okay, we have a dead power supply. See that? So I've got like 0.1 volt and 2 amps there being drawn. So looks like we have a dead short across the power supply terminals, which probably means that we have dead power supply FETs. So let's bust inside and have a look. You can see the constant current LED lit up there. There you go. It's telling us that it's limiting the current here. This one I don't think had a sticker on the box. Oh wait, yes it does. It says faulty when powering up, blows fuse. This one did actually have a sticker on the box. Yeah, it says faulty when powering up, blows fuse. But unless I put the power wires in backwards again, this is blowing the fuses the second that the power wires are fitted. So let's just double check. ground in there. Yeah, no, the power wires are in the correct way round, so that's not a problem. So the reason that this amp is so massive is because it's a very old Class AB circuit design. Its size is not relevant to its performance, if that makes sense. I mean, it's a relatively decently powered Class AB, but it's not a particularly nice Class AB. I don't think it's got a great design to it, but I don't know. We'll see. Yeah, I think it's a single-sided PCB. Ah, okay. Well, there's your answer. We have actually. This is completely different. I've worked on this like an amplifier that looks almost identical to this before, and the whole PCB is like upside down. So when you take the back off, the cover off there, you're actually presented with the underside of the board, and there's like a bunch of daughter boards and wires and all sorts going on. This is much different. Oh my god, look at the board flex though. I wonder if I can capture this on camera somehow. Absolutely monstrous amounts of board flex. I suspect that has had something to do with the failure here. These transformers are very, very wobbly. Possibly completely loose and desoldered from the back. So we have a blown power supply section. Okay, let's just out of curiosity see what the output MOSFET, sorry, not MOSFETs, these are Class AB, these are transistors. See what the output transistors are saying. Any shorts on the outputs? Oh, that's a low resistance. My multimeter camera isn't working because the connector is absolutely rubbish. I want to just try one more time and see if I can get it to sort of reliably work. I'm just going to deactivate, reactivate. See if it will reliably work. Okay, there we go. So have a look at this. So across the outer legs of this transistor we have 107. So I think we're going to have a shorted transistor somewhere. Oh no, maybe not. You do sometimes get low resistance across the legs 1 and 3. Okay, now this could be normal. The main issue is if you have a short between legs 2 and 3 or 1 and 2. But on Class AB, if you see a low resistance between 1 and 3, that doesn't necessarily mean that there's a problem. Okay. So output's looking okay so far. Yep. Okay, so might just be a power supply failure due to vibration damage then. So we're going to have to strip the board out and see what we've got going on underneath here anyway to make a repair for starters. Yeah, the board, this is probably one of the most flexible boards that I've come across in quite some time. Why is the board so huge? Well, possibly a couple of reasons. One reason could be to make the amplifier look bigger than it is, and therefore have like a better appeal to the end user. But another reason could be this is a Class AB amplifier, and Class ABs run hot. So the more heatsink you've got, the better really for it. So having everything spaced out a bit more and having a bigger heatsink will actually allow you to run this amplifier harder for longer because it won't overheat as quickly. The heatsink won't saturate as quickly because there's more thermal mass. So that's another possible reason. But yeah, everything is mega spaced out. You could definitely squeeze this into a smaller heatsink if you wanted to. Exactly, yeah, $2 worth of PCB standoffs would have made a world of difference to this thing. Yeah, big difference. Big crack in this MOSFET. Massive crack in this MOSFET. Right, I think that's all the screws, so this should pop out now. Oh, okay, we need to go this way a little bit first, then that side comes out, then this side comes out. Okay, cool, cool. Remove that LED header. There we go. Okay. Oh my god, this board is so thin. Look at this. Wow, this is so bendy. It's like paper. Oh my days. That is one of the thinnest boards. Oh my gosh. Insane. Okay, so let's have a look then at the power supply section, because that's obviously where we've got a failure. I want to check all of the solder joints on the transformers and stuff. Man, if you could feel this thing's so... Got to run. Thanks for the class. Cheers, Sam. See you later, Josh. Thanks for jumping on, man. I always appreciate you. Alright, let's have a look then at all these solder joints on the back here. Just kind of going over them, seeing whether we've got any... You know what, actually? Despite the crazy amounts of board flex, I'm not actually yet seeing any broken solder connection. Oh wait, I see one. Although that could have just been from heat. Let's have a look on the bottom of the heatsink here. So basically I see one FET that doesn't have any solder in it. But that could just be because it overheated so much the solder melted and dripped out. So let's have a look. I don't see any soldered drops on the heatsink here, so I don't think that that's the case. So it's very difficult to tell. I don't know if this was from factory or whether this has happened as a result of the failure, but this MOSFET here, that leg doesn't have any solder in it. So yeah, that could have happened when the amp failed and it just got so hot the solder dripped out. But to be honest, given the fact that none of the other FETs here have that issue, it's kind of maybe possible that that wasn't really soldered from factory, and then this FET failed, sending, like, you know, 12 volts or causing issues with the drive circuit or whatever to the other FETs, and then they all shorted as well. As far as the solder joints on the transformers go, all look pretty brand new, pretty factory. Not really seeing any issues there. If I give the transformers a wiggle, there's not really any issues on those solder joints. Let's check the MOSFETs on this side here. Yeah, no issues there. So it looks like it might have just been one solder connection that wasn't made properly that caused this to fail. So let's get rid of all these FETs. Let's get all these FETs out and check the drive circuit health status afterwards and go from there. This board flex is more than the speaker it's driving. Well, very possibly, yeah. Very possibly. The nice thing about these boards is the thermal mass is super low, so these should all desolder very quickly. Yeah, nice and quick. The tracers hold their heat quite nicely because there's not really there's not really any ways that the heat can go. There's very low thermal mass here, so yeah, desoldering really nice and quick. Okay, looks good that side. Flip her over. Hey Sam, got a Hyphonics Brutus 1500, turns on but no sound. Where to look? Depends on what circuit that Hyphonics is using. If it's using the generic kind of Maxonics circuit with a certain type of driver card on the output section, I can tell you exactly which two transistors to replace, and the amplifier will probably come straight back to life. There's a pretty extreme design flaw with a lot of the Maxonics Class D circuits, and there's two transistors which are heavily overworked. You just need to replace them, and it rectifies it. It brings almost all of those Hyphonics amplifiers back to life. So if you want to send me a picture of the board to my Bearvid's Facebook page, I'll be able to tell you if that's the case, and I'll be able to tell you which transistors to replace. Just checking for solder bridges here. Alright, let's flip her over. Dude, there's a big storm here. My power went out, but I got to watch Bearvid, so I switched to data. Oh man, that's dedication. Holy crap. Thanks for that. Right, I've got a couple of gate resistors that we need to replace as well by the looks of it. Well, actually, one main gate resistor. Actually, hey! Hang on a minute! You see this gate resistor? So if you look at the gate resistors, right? All the gate resistors are fine, apart from this one. Now this one, when flipped over, was the one that had no solder on the drain. So yes, that almost confirms for sure that this MOSFET didn't have any solder on the drain from factory, was making an intermittent connection, therefore failed, and it sent 12 volts down the gate path to all the rest of the MOSFETs, because all of the other gate resistors, even though this one looks a bit burnt, it's actually just covered in soot from the MOSFETs around it failing. There we go, cleaned right up. So yeah, that's exactly what happened. This one failed due to not having any solder on one of the legs of the MOSFETs from factory. Damn. Where are the drivers? The drivers are in the middle of the board here. Let's see whether we've got any visible damage on these. They're pretty big drivers. These might actually be fine. We'll have to have a check. We'll fit some new MOSFETs and we'll see what the drive waves look like, but I'm sure the drivers on this are actually probably fine. The gate resistors that are used here are 22 ohms by the looks of it. I think I've got some spare 22s. I like it when they're so cheap they just use one gate resistor per bank and run jumps. I haven't seen that yet, I don't think. That would be jokes, but I don't think I've come across that yet. That's pretty bad. That would be really cheaping out. Like, resistors are cheap, you know? Alright, that's that resistor out of here. Suck the solder from those holes. What solder socket do you use? Just the generic cheap one. It's like, these are like £1 or like £3 from anywhere, eBay, Amazon. But the big difference is I have a silicon tip on the end. So having a silicon tip on the end of the solder sucker makes a huge difference to its performance. It allows an airtight seal against the end. Yeah, it makes a massive difference. The only problem with these is that after a while, the latch on the button weakens, so they like set themselves off after a while. So you see, this one's kind of on its way out. Just a gentle touch of the button sets it off. So I'll probably need a new one at some point, or I could just 3D print a new latch and then it would work fine again. Super simple. Nah, see, I love this thing. It doesn't take any time to heat up, although I have to use my iron with it. I don't have to really clean it out because it cleans itself out by when you push the button back in, it pushes the solder out. Honestly, I haven't used a Hacko yet, so I can't speak for that. But I have used desoldering guns, cheaper ones, and they actually take more time than this. This doesn't really use much energy on the thumb, and it keeps my thumb nice and strong, you know. It doesn't really use that much energy. I don't know, I kind of like the analog mechanicalness of it. It's cheap, isn't it? It saves me money. Yeah, Hacko, I could buy a Hacko desoldering thing, cost me £400. I'll tell you now, there's much better things I'd rather spend £400 on. and I can still do my job with this. So wait till you're 50, you'll be sorry, sincerely, old dude. That's a point. I don't know. Do you think? Do you reckon? I don't know. I would have thought by now, after like 6 to 8 years of doing this job, I would have felt some issue in my thumb. Repetitive strain injury? Maybe? Doesn't feel that bad. But maybe it will come back to bite me. Maybe I should get a Hako. Now they're 400 here in the UK. They're 200 bucks to you in the States, but they're 400 for me. All right. Yeah, let's load this up with some. Well, let's just check the gate drive first. So let's flip that over. Power supply on. Turn the voltage back up to 9. Let's just check the drive waves. See how they're faring. Okay, how are we looking on the scope here? Zoom in a little bit. Oh, very slow duty cycle build. Holy crap, that's very slow. That is mega slow. 33 kilohertz. Look at this. Look how slow this is, this duty cycle build. Lots of noise on the scope for some reason. But look how slow that is. We're still going. Still not 50% yet. Let's get a readout of the duty cycle. Hang on a minute. Voltage, RMS, channel 1, time, frequency, duty cycle. Right. So it doesn't even build to 50%. What? The final resting point of the duty cycle on this power supply is only 41%. That's kind of sandbagging the power supply quite badly. What's this using? Is this using a 3525 or is it using a TL494? No, it's using a 494. I might have to modify that because too much voltage is remaining on pin 4 in order for that to happen. Pin 4 needs to end up basically at ground to get, 49.5% duty cycle or whatever it is, with a bit of dead time for the power supply FETs. But this is ending up at like 40 at resting point. That's not really enough for optimal use, optimal power supply operation. My probe is fucked. The reason that there's so much noise on the scope, I think this probe is kind of fucked. I wonder if I've got another one I can use. But the reason there's so much noise is basically my probe. It's just a bit shit. 21, 30, 35, 37, 38, 39, 40. Yeah, I might have to make some changes to that PWM gen over at the 494. That nice soft start is for charging large rail caps. Spoiler alert. Spoiler alert. There aren't any large rail caps on this board. You've got 2 caps per rail. 4700 microfarads per rail. So what's that? Yeah, it's just like about 9k microfarads. Not really excessive. I've seen amplifiers with 10,000 microfarads per rail with a much faster duty cycle ramp than that. Oh, that is true. I'm at 9.6 volts. Let's test it again at 12. See if that makes a difference. It shouldn't do, because the voltage on pin 4 of the TL494 isn't really relevant. It's still pretty slow, and it still ends up at 41%. What about 14 volts? 15 volts, there we go. 40%. Is it any quicker though? Still pretty slow. I mean, it's alright. The speed of the duty cycle ramp is fine. That's pretty average. But the duty cycle ends up at 40. Yeah, that's not great. So that means that on pin 4 of the TL494 down here, that means that there's still some voltage floating there. So you can see it's going to start off high to ramp up the duty cycle, and then it settles at. Oh my god, there's so much noise. I'm gonna change my probe. Hang on a minute. I can't deal with this amount of noise on the scope. I need to make a change somewhere. Right, what are we saying? Is this one any better? No, maybe it's I have a poor ground reference for the scope. Let me just hook up a ground probe real quick. Maybe it's like loosened itself over time. Let me hook up a ground wire for the scope real quick, just to sort that out a bit. Where is my ground wire for the scope probe? Here's a very small one. I've got to find a really nearby ground reference. Hang on a minute. Let's get the multimeter, that will help. Right, ground reference. Is there anything nearby? Anything nearby with ground on it? There we go, that's got ground on it, that'll do. So I'll hook up a ground reference to there. Alright, let's try that again. Turn the voltage back down again. Don't need 14 volts now. Oh, what's wrong now? Right, that's much better. Look, there's no noise on the scope now. So yeah, I need to sort out my scope ground reference a little bit. But anyway, that looks nice. Pin 4. Let's have a probe of pin 4. So here we go. We've changed to a ×1. So voltage on here ends up at like 2 millivolts. That's off. That's coming down quite a bit. So basically, yeah, that needs to be at ground basically to give us our 49.5%. So what I'm going to do now is I'm going to actually probe the output of the 494 instead, which is pin 9 or 10. So I'm going to do that. Okay, and let's have a look on the scope screen at that. So that should tell us our duty cycle. 41%. Actually, this probe is broken as well. So if I now ground somehow with a little spare bit of wire, if I now ground pin 4, we should see that jump up to like 50% duty cycle. Do I have a little spare bit of wire somewhere? Somewhere on the bench maybe. A little bit of jumper wire somewhere. What's this? This might do. Yeah, let's just try and fucking... Maybe I'll do it with a screwdriver. Really? There we go. This is a bit thick, but it'll have to do for now. So let's just touch that on ground there. So if I ground pin 4, let's just make a nice small little probe with this bit of wire here. So I'm going to ground pin 4, which is here. We should see that duty cycle jump up. So we are at 41. Touch that. Yeah, oh, now we're at... If I ground pin 4, we jump up to 45%. Okay, so we don't ever make it quite to like 49, 50. So without the ground wire attached, we're at 41. When we ground pin 4, we end up at 45.3. That might be the maximum of the 494, to be honest. But you can see that there's a bit of a difference there between when we ground it and when we don't. And that will make a bit of a difference to the effectiveness of the power supply, but it's whatever. Anyway, what was I doing? Let's just check the drive waves at the gate. I think it looks okay. I think we just confirmed that it looked alright. I'm going to swap these probes back, actually. because that one has an intermittent connection. Yep, so we have good drive on that bank, good drive on that bank looks okay. So yeah, we've got good drive everywhere, that all looks fine. So just needs new power supply FETs and this amp will be back up and running again. Whew. Yeah, basically like I would say most decent technicians, their workbench kind of looks like this. Like, hey, this is what it is, isn't it? You work. You come into the workshop to work, not to tidy up. I do tidy up every now and then, but it always, like, within a day of working, it looks like a fucking mess again. So guys, I hope you enjoyed that. I'm going to call it here. If you enjoyed it, leave a like. Oh, it's always appreciated. If you have TikTok already, search for BearVids on TikTok. I'm doing really cool videos on TikTok. Really cool little like 2-3 minute repair summaries. They're really fast paced. They're really fun to watch. But yeah, stick around, subscribe for the next live stream, and I'll see you in the next one. If you've got any last minute Q&A, give me a shout. I'll stay on here for another minute or so. While I turn off all my cameras and shears. It's BearVids After Dark. Ah, this is cool. This is nice. BearVids After Dark. Anonymous. Hacking. Brazilian amps, worth the risk? Absolutely. There's not really a risk. Like, genuinely, they're fine. As long as you don't buy Sound Digital or Stetson, you're fine. Get something like modern from Tower Amps, or Banda is a bit hit and miss. Like, honestly, Paris are the best. Next best selection would be Tower Amps. Treat it right, you're gonna have a good time. Yeah, with anything, you can buy one and it ends up being a dud. Bad components, bad MOSFETs from factory. It's difficult. But that can happen with any brand. So yeah, absolutely, for the price, worth the risk. Yeah, the Tower Amps Smart 8, I'd love to get my hands on and do a review of. Is Lanzar Opti still underrated? Nah, Lanzar Opti's sold out. They're super cheap, rubbish Chinese stuff nowadays. I would avoid Lanzar these days, to be honest, if you can. I tried to plug your TikTok but got blocked. Oh, like sending the link. Yeah, that you can't send links on YouTube chat for some reason. It's long. But yeah, guys, hope you enjoyed. I'll see you in the next one. Take it easy.